chicken coop, 3 types of chickens, and I'm fencing these chickens in. I want to keep the 3 types of chickens separate, and I'm protecting them from fox. I know I have 1,200 square feet of area, and I want to find the dimensions of this chicken coop that will minimize cost. Now, it's interesting that the outer fence costs more. Of course, that makes sense. It's a bigger, stronger fence than the inner fence. So let's just set up our variables first. Let's call this length x, just for fun.
That's good.
So let's see, if this is x long and it's $3 per foot, can I just say that's going to cost $3x? And this is going to cost $2x and $2x and $3x. So far, so good. In terms of this length, let's call this y. So this fence is going to cost 3 times y dollars. This part of the fence is going to cost 3 times y dollars. Are we okay? Okay, so if I want to minimize the cost, let's come up with a cost equation. Can I just add up all of these together for my cost?
Absolutely.
All right, here I go. 3x plus 2x plus 2x plus 3x. I think that's 10x. Did I do that right?
Looks good.
Plus 3x plus 3y plus 3y is 6y. There's an equation for my cost. But look at all these variables. I've got cost as a variable, x and y as a variable. Before I do the derivative, I want to get rid of one of these variables. We've done this a lot. So let's go back to the question and see what information I haven't used. And there we go. I know a relationship between x and y. The area is 1,200 square feet. So here I go. Now, I've kind of labeled everything with those 3's, but remember, that's just the cost. So let's go back and really think about what the dimensions of this rectangle are. What really are the dimensions? The dimensions are really just x by y, right? The area has nothing to do with the cost. So area is x times y.
So that could be a little confusing. I was looking at it like the 3x, so that really the dimensions are x times y. I'm sorry, you just said this, but I'm saying it again.
Yeah, no,
so so the dimensions are x and y. Those 3's and 2's were just because the x dimension is like $3 times x, and the y dimension was 3 times y, and then those 2's in the middle. Got it.
You got
Okay,
it.
but there's, all right.
Okay.
Okay.
So
Farmers must be really good at calculus.
Yeah.
They do this a lot, I guess.
Area is 1,200. I think I'm just going to get y by itself, because I like x's better than y's. I don't know why. I don't know why. Oh, I get it. Y. Oh, okay. So, there we go. I've got an expression for y that I'm going to pop right in for that y, so that I have a cost equation. I'll just call that C. Just in terms of one variable. In this case, it's going to be x. How am I doing?
Looks fabulous. Excellent.
Okay, before I want to do any derivatives, I want to clean this up a little bit. So I think I can multiply that 6 times the 1,200. 7,200. Did I do my multiplication correctly?
That is correct.
Okay. So I have an equation. I want to find the maximum or the minimum of this. In this case, I want to find the minimum cost. So I want to see when this has a minimum, when this function has a minimum. I could throw that in my calculator and see if I could find a minimum there. But to find it exactly, I'm going to use calculus. I'm going to take the derivative, see when the derivative is 0, when the slope is 0 or undefined. All right, I'm not liking that fraction though. Can I rewrite this before I take the derivative? We're good at this point. I'm just rewriting the function as x to the -1. I think I'm ready to take the derivative. What do you think?
I think you are.
Cost? All right, the derivative of my cost is equal to derivative of 10x is 10. Derivative of this guy is -7,200 times x to the -2. Okay. There's the derivative. I want to find a critical point because I'm looking for a minimum. So I'm going to set this first derivative equal to 0. Now all I have to do is solve this. Whenever I see a negative exponent, I like just rewriting it in this case. And let's bring it on over. So am I going to do too much at once? Maybe I'll just do it separately. So I'm subtracting that, or adding it to both sides. Are we okay? Now I'm going to rewrite that negative exponent as a positive exponent. It's just easier for me. You don't have to do it this way. All right, I think we can see we need to get rid of that denominator. So I'm going to multiply both sides by the denominator. It's a tried and true strategy we've talked about a lot. I'm honing in, divide by 10. And let's take the square root of that, which is approximately 26.8, give or take.
Wow, you did that in your head, Miss Stewart?
I didn't.
Wow.
Now, do I have to worry about the plus or minus?
I think we're talking about lengths of fence, or actually cost in this case. Is that correct? No, x is length of fence. I'm sorry. So it's pretty much not going to be negative.
Exactly. So we don't have to worry about the negative part. So there's my x. Let's go back to my mission. Find the dimensions that will minimize cost. Okay, I have my x. All I have to do now is find my y. So let's hunt back and find, hey, this should do it for me. That's a nice clear equation with y isolated already, so I can plug that in. Of course, technically, I don't want to just plug in the rounded thing, right? You want to plug in a few more digits.
I think you're missing a 0 on top there.
Thank you. Whatever value you actually had in the calculator, you want to divide by that to get your y, which if my calculations
You're going to do that in your head too, Miss Stewart? Very impressive.
44.7. So my dimensions would be about 26.8 feet by about 44.7 feet. That would be the size of the rectangle that would minimize the cost of my fencing. So let's back up a little bit and just touch on a couple of things. Some of you might be wondering, hey, wasn't there another critical point? You thinkers out there? And you're right. There would have been a critical point when x was 0. Because remember, critical points happen when my first derivative is equal to 0 or undefined. And of course, this first derivative is undefined when x is 0. But we don't really have to worry about that in this case, because if x is 0, then my chicken coop doesn't even exist. So your math is a little different when you're in the context of a story. You don't have to worry about negative values. You don't have to worry about 0 dimensions. So the other thing we need to do is I just kind of assume that that would minimize my cost. This could be a maximum for all I know. So you should always verify that you have in fact found a minimum. So since we worked with x, let's work with our x. Let's pick a value less than 26.8. I know we like to pick 0, but I can't pick 0 because that's going to give me something undefined. So let's just pick 1. That's smaller than 26.8. If I plug in 1 into my derivative, 10 minus 7,200, remember that's going to be a denominator. So divided by 1 squared. That's just 10 minus 7,200. That's going to give me a negative value. So my first derivative is negative there. Okay, let's plug in, I don't know, 100. Okay, so I'm just going to do this here. 10 minus 7,200 over 100 squared, right? This one you might have to think about a little bit. 100 squared, 1, 2, 3, 4.
Well, that's less than 1.
It's less than
sure.
1, so 10 minus something less than 1, that's going to be positive. All right, I'm feeling pretty good. I've got a negative slope and then a positive slope. I am, in fact, finding a minimum there.
That's great. And you know, the way these problems work typically is that it wouldn't even really make sense to ask it the other way. I mean, if the question were asked, find the dimensions that will maximize cost, I mean, it would be, you know, you would have an infinitely long and infinitely thin chicken coop. It would be kind of a silly question to ask. So generally, if you're asked for a minimum, the point you get is going to be a minimum. Wouldn't you say, Ms. Stewart?
I would say